You find
Good
any
afternoon,
blank
sir.
is there on your screen?
Yes, sir.
Yes, sir.
Okay. Then the familiar thing, we consider one vertical plane. Yes. What happened? Can you hear me? Anyway.
Yes, sir.
We can hear you.
Yes, sir. Yes, sir.
Okay. So this was the reference vertical plane named as VP.
Yes, sir. Yes.
One object is placed in front of that. We are projecting it as if here is the eye of the viewer, and the eye of the viewer is so big that line of sides are parallel to each other and perpendicular to this plane. So this is the projection on the vertical plane, which is normally called the front view, view from front, or most popularly that is the elevation. Then we considered one horizontal plane. On that reference horizontal plane, we project this object just looking from top, and this is the view from top, or top view, or popularly known as plane. Then we considered these two mutually perpendicular planes, VP and HP, those are infinite in size and intersecting each other at this line XY. And we consider a small portion of those infinite planes with reference to this small portion taken out of that intersecting VP and HP. The position or those angles or dihedral angles with reference to this VP and HP are mentioned in this way. If you are here, the observer, then with reference to you, this will be the backside of the vertical plane or behind vertical plane. This is in front of vertical plane. This space is above HP. This space is below HP. And this portion in front of VP and above HP, this is the first quadrant. Similarly, you know, this is second quadrant, third quadrant, fourth quadrant. And this is as it is rather written. Now, if we see from this direction, for these four planes, these two mutually perpendicular infinite planes, they will look like this. Okay, so if you see from this direction, this XY line, the line of intersection between VP and HP, they will come to this point as if it is the origin, and like your school days trigonometry, those subdivisions of this space is first quadrant, second quadrant, third and fourth. Now we considered one more plane which is perpendicular to both VP and HP. It is the profile plane. Then the formality of this is that place the object. Suppose object is a point. We start from that basic or primary object. It's a point named capital A, and drop perpendicular to 3 reference plane on VP. This is the foot of the perpendicular. Now perpendicular drawn on this plane HP from this point capital A. This is named as small a, and similarly this is the foot of the perpendicular drawn on this profile plane. It is small a with double dash. So once you know this thing, we give names of this A prime and A double prime. This is called the view from top when we project this point capital A placed in first quadrant, or top view or plane. This is A prime is view from front or front view or elevation. And what about the name of this? This is view from side. So this is left side view with reference to the observer. And this 3D presentation is simplified to for convenience of our use, for industrial use, for academic use, etc. The subject is open this space by rotating these planes HP about the line XY through an angle 90 degree, and this profile plane PP rotate it through 90 degree in this direction about this line of intersection between VP and PP. So ultimately you will find when you rotate this, the things are placed on a 2D paper-like thing. Okay. So VP and HP coming on that plane, and VP and PP coming also on the same plane. And the real object, the capital A, that point is not presented here. Rather, its views are presented on three different portions. One is the part of the VP, other is the part of the HP, and other third one is the part of the profile plane PP. And all these three plate-like things like VP part, PP part, and HP part, those are placed on a single plane, as if on a single white piece of paper we have made these three rectangles, and these views are presented there. Now, what about this line? This line is line of intersection between VP and HP. Now, what about this distance? This distance is distance of the elevation as well as this distance, and this is the distance of point capital A from the horizontal plane, DH, and distance from horizontal plane is available in vertical plane side. So sometime if we don't try to understand thing, at least mechanically we should try to remember the formula like thing. So distance of the point from this plane HP is here. And distance of the point from VP, it is here. Otherwise, if you can visualize, that's nice. It's fantastic. So this distance of plane from the ground line, that is the distance of the object point capital A from the vertical plane, that is dV. And one more thing, when we open this 90-degree space, make it 180 degree, naturally both of these coming on the same plane platform, this green line also rotates through 90 degree, and finally it becomes a single straight line. This was the portion shown on the vertical plane, this was the portion shown on the horizontal plane, but ultimately when you open the space and VP and HP overlapped on the same plane, this green line coming to a single straight line perpendicular to XY, and this line is called the projector. So elevation and plane, they must be connected by this single straight line, which is called projector, perpendicular to the ground line XY. Now in some book you will find instead of line XY, it is written GL, capital G, capital L, that is ground line. Okay, so nothing to worry about that. There is the line of intersection between those two reference planes, VP and HP. Now once we have this information, then regarding the third plane, that is profile plane, what about the distances? Distance is, let us go back to the previous figure and remove these other information. Okay. Now distance of this side view A double prime from the vertical plane or from this reference axis, this is same as this distance dV, and height of this side view A double prime from this reference axis is same as this distance of the point capital A from the horizontal plane. And this simple grammar we maintain here, that this distance is dv, this distance is dh, that is distance from the horizontal plane, that is the height which is available here, and this is the distance, this is the distance from the other plane, that is the vertical plane. Okay, and this is the distance on the VP side, whatever we are getting, that is the distance from the other plane, that is HP. So distance from the horizontal plane, and it is distance from the horizontal plane. And how to draw it? Either the first process is take this point as center, take this distance dv as radius, rotate through a 90-degree arc, then reach to this point, draw a vertical line, a line perpendicular to this horizontal line, XY line extended, and reach up to this. But when you are working with your pencil, eraser, scale, drafter, etc., it will not give you like this software, like this fine, rather point of intersection exactly. What we need to do, that is draw a vertical line through this point, and from eye estimation we can extend it little bit above this yellow level. Then extend this horizontal line drawn through the elevation A like this. Now this point of intersection is the side view A double prime. Okay, so please remember, and things are very simple. You will find interest, but proper practice is required, otherwise it will be something treacherous. Okay, so formally what we do not show this thing, the rectangle representing the part of the vertical plane, this rectangle representing the part of the pictorial plane, and the rectangle representing the part of the horizontal plane, not in that way. Simply one XY line. If end view or side view is asked for, then draw this axis, then do these geometrical operations on this with the informations given, dh, dv, etc., and that's all. And this was such a thing. And when we rotate this plane, this HP, sorry. When we rotate this HP through 90-degree in this direction, naturally, this part of the HP also rotated about this point and it travels upward. So if there is any point in second quadrant or on this side on HP, it will travel to upper side with reference to this ground line. And as you know that for first quadrant, it is coming down. For third quadrant, this plane will shift upward above XY line and elevation will be below XY line. And that we discussed in your previous class. And in short, we can think about those individual things in this way. Point A in first quadrant. This is the physical presentation. We project it on horizontal plane, on vertical plane, the plane small a, elevation small a dash. Then we rotate this HP so that we get one 2D presentation. So when we rotate here, the point which was located here, the plane, it comes in this way. And this type of 3D presentations are not used. This thing is followed, and this is the grammar of this subject. Distance from the horizontal plane in elevation, distance from the vertical plane in plane, a single straight line, thin straight line indicating perpendicular to the ground line, and this line will connect the plane and elevation. Okay, so please remember. Next thing, when there is a point capital B in second quadrant, So कभी-कभी बीच में सर yes sir no sir very good sir बोलते जाइए, नहीं तो I will be in some confusion whether this is just a one-way journey or not.
Yes, sir.
Yes, sir. Okay. Now a point B is there in second quadrant. It is projected on the vertical plane. We get the elevation projected on the horizontal plane. This is the plan. Now as we rotate the horizontal plane in this second diagram, we get the elevation is in its position, but the plane which was earlier here, it is shifted to this location. And with reference to this XY line, the both plane and elevation, they are coming above the ground line XY. And what about this distance? Distance of plane, that is distance from the vertical plane, and the height of elevation, that is the height of the point from the horizontal plane or distance from the horizontal plane, it is available in elevation. So these informations will be given. Elevation gives the distance from the horizontal plane, plane gives distance from the vertical plane. Next thing, let us consider point C in third quadrant. It is here. And in the second figure, when we rotate the HP 90 degree to make it on a single flat surface, that is, this plane C is coming here. And it will be simply opposite to the first quadrant projection or first angle projection. Plane will be above GL. Elevation will be below GL. Distance of elevation will be distance from the horizontal plane. Distance of plane should be distance from vertical plane. And the last one, the fourth quadrant problem, point capital D. It is here. Projection on the horizontal plane, the plane, projection on the vertical plane, that's the elevation, rotate the horizontal plane through an angle 90 degree. So the plane D comes here below ground line, and according to the grammar of this subject, this is the presentation what we need to do always. That is the XY line or ground line, elevation, distance of elevation from GL is the height of the point or distance of the point D from the horizontal plane, and this is the plane distance is distance from the vertical plane DV, this one. So please remember these formalities, but we will stick to this first angle projection normally for throughout this subject. When elevation is above ground line, plane is below ground line. Okay. Next thing we discussed, that is regarding point the problem 1. Points P, Q, R and S are situated in different quadrants. P 40 mm above HP, 20 mm in front of VP. Now this is the presentation for point capital P. Small p in plane, small p dash in elevation. Distance of the point from horizontal plane is available in height of the elevation or distance of the elevation from GL, that is 40, that is 20. And in our last class, I asked you to get a screenshot of this so that you can work it with afterwards. If by any chance you miss anything, these documents or this information will be there in your database, and just consult it. But not necessarily you have to follow this thing only. There are so many information. There are so many videos in YouTube you will find, and there are so many good books on engineering drawing. ND Bhatt and K. Venugopal is normally we prescribe, we refer. But truly speaking, there are so many other good books. Point B, now point Q rather. So Q is 45 mm above HP. So when it is 45 mm above HP, it means it is elevation of Q, and 15 mm in front, 15 mm behind VP. It means this is the plane Q and second quadrant means plane will be above GL. For third one, capital R is 50 mm below HP and 25 mm behind VP. So that is in third quadrant. So 25 millimeter behind VP, distance from VP, it is coming in plane, and distance from horizontal plane, that is 50 millimeter below HP. So this is 50 millimeter, and here it is the elevation or dash. And for S and S dash, for the fourth part, 45 millimeter below HP. So distance from the HP, it is in elevation. So 45 millimeter, it is showing the elevation, and 10 millimeter in front of VP, that is distance from VP is available in plane. This is the plane. Capital S is the point, real. Then small s is the plane, small s dash is the elevation. And other names are, plane means view from top or top view, elevation means view from front or front view. So please understand these things, these are very primary. Okay. Now for problem 2, these two are given in detail. There remaining C, D and E, we are supposed to solve it. And then for point A and point B, the solutions are given 45 millimeter above HP. So that is the elevation. Then 25 millimeter in front of VP, that is the plane. So once we draw the plane and elevation, then next step is draw this line. Step 3. Step 4. Draw a line parallel to ground line XY passing through the plane. Then step 5 is draw this quarter circular arc to reach up to this level. Then step 6 is draw a vertical line. We can extend it a little bit. Step 7 is draw a line parallel to HP, either this GL, through the elevation, and we get the step 8 as the side view or view from left. View from left for first quadrant, it will be coming on right, and view from right will be coming on the left. So accordingly, you need to place this axis. Now, once we do this thing, then definitely we can understand the next problem also. Only difference is it is the view from right. So for view from right, the side view will be coming on the left, and this distance dV is maintained here. This distance 45 dH is maintained here. Similarly, side view will be at this level 20. The side view will be at the same distance from this axis 40. But we have used this mechanism that project it, get this point of intersection, and from here draw a 45-degree line, get this point of intersection, and remaining part is same. So whether you draw a single circular arc of 90 degree or draw a 45-degree line, or we can draw a 45-degree line here, draw this horizontal line, get the point of intersection, and through this point you draw this vertical projector. Everything you will get the same thing. DH and DV are maintained. Distance from vertical plane, distance from horizontal plane. The next thing that also most likely we discussed. Just hold a minute. The vertical plane, the horizontal plane, and here we have two distinct points, capital A and capital B, in first quadrant. For the time being, you forget about this green line, these blue lines, etc., and also these red lines. Simply you concentrate on 2 points, capital A and capital B. Next, we project it on a horizontal plane. This is the plane project it on the vertical plane. This is the elevation of the point capital A. Project on the horizontal plane, we get the plan of capital B. Project on the vertical plane, we get the elevation of the point capital B. Now, as you know, if we connect 2 points or 2 locations by the shortest route, it gives a straight line. So join these 2 points A and B, we get this straight line. Similarly, if we join the 2 elevation points A dash and B dash, then we get this line as elevation of the line capital AB. And simply we join small a with small b, we get this line small ab, that is the plane of the line. And when we consider as a whole, then shadow of this stick or rod AB we get here on the VP as the line A dash B dash, and the shadow formed on the horizontal plane here. So this is the plane of the straight line. Now here we are considering the whole thing. Otherwise, according to our previous discussion, we can think about the individual location of these terminal points capital A and capital B, and automatically you will get the elevation and plane coming in that similar fashion. That is point A, capital A, projection on horizontal plane, the plane projection on the vertical plane, that is the elevation. This is another isolated point capital B, project on the vertical plane, we get the elevation. B dash, project on the horizontal plane, we get the plane small b. Okay. So in both the ways you can do, but when a problem is there, defines the straight line as a whole or deals with the straight line as a whole, then you need to think in that manner. In all problems, it will not be given there is a point capital A in first quadrant, there is a point capital B in first quadrant, and the projectors through A and B are this much distance. Problems may be given in that form, but those are very preliminary, satisfying some geometrical criteria. But we need to think as a whole when we'll take up the problem for the straight line. Okay, so just that much we must remember. But the preliminary things, it should always be there in our back of the mind that capital A exists separately, capital B exists separately, and plan of capital A, that is A, plan of capital B, that is small b, elevation of capital A, small a dash, and elevation of capital B, that is small b dash. The pair of these plan elevation for capital A and pair of this plan elevation of capital B, those are connected by a single projected line perpendicular to the XY line. Okay. Now here we have some problems when individual points, the terminal points A and B are given, and the distance between the projectors through A and B, these are mentioned. So it is something like that. 3A, draw elevation plan and view from left of the line AB when A is 10 millimeter above HP. (10 millimeter above HP means this is 10 millimeter elevation of A, 20 millimeter in front of VP, that is in plane. Then B is 40 millimeter above HP. So this is the elevation 40 millimeter, and 45 millimeter in front of VP, that the distance from the vertical plane that is coming in plane 45 millimeter. And one thing without dimension, the problem, rather this whatever diagram you have drawn, it is incomplete and you cannot claim the complete marks. That is, if you say that plan is drawn, elevation is drawn, side view is drawn, sir, what is the wrong with it? It is incomplete because location of the elevation 10 millimeter from the ground line, location of the elevation B dash is 40 millimeter from ground line, representing height of point capital A 10 millimeter, height of point capital B 40 millimeter, etc. So all these things you have to do it. These are the compulsory part of the solution. Then it is mentioned the distance between the projectors through A and B is 40 millimeter. Measured along GL being 40 millimeters. Okay, so this is the solution. And when you need to draw the side view, or rather the view from left here, then that same formality. This axis, step 1, then step 2, up to this, then step 3, to reach up to this level indicated by this heights given 4. So this is the side view from left. And same thing you will get for the other parts. This was 3A, this is 3B, and this is 3C. Just allow me to erase this excess information. Otherwise, it may be clumsy. Now for part B, draw elevation plan and view from right of the line capital C, capital D, when C is on HP. Now when there is a point on HP, then what you can guess from its position? There is a point on HP. Suppose here is a point capital E. Then you project it on the vertical plane. Now as it is located on the horizontal plane, so definitely its elevation will be located on the ground line. And similarly, if we have a point on the vertical plane, capital B, and when we project on the horizontal plane, that is view from top, its plane will be here located on the ground line. And naturally, the same point will be plane A and the same point will be elevation B prime. Okay, so this ability of visualizing about the position of the object, its projections, etc., it is very important, and you must try with different objects. Suppose you take one stick, maybe your length 1 foot, 1 foot or 1.5 foot, and you try with several positions, and you place it parallel to both the planes. Okay, then what about the shadow formed on this horizontal plane? If it is the actual length L, then what about the length of the plane AB? This will also be L. And what about the elevation, length of the elevation? A dash B dash, that will also be L. And names are like this. Then its plane AB and elevation A dash B dash. Okay, so length of elevation is capital L, length of plane is also capital L, when the real length or true length of the line capital A, capital B is L. Okay, so that ability of visualization is very important. Now let us go back to that part B of the problem 3. Okay. Draw elevation plan and view from right of the line CD when C is on HP and 30 mm in front of VP. So elevation of C will be on the ground line because the height is 0 and plan is at a distance of 30 mm. Similarly, point D 35 mm above HP and D on VP. So it is similar to that previous diagram. When D is on VP, so its plane will be on the ground line and its elevation will be at the height mentioned, that is 35 mm. Then we join this small c and small d. Then we join small c dash and small d dash. These are the plane and elevation. Next part is simple. C, step 1, 45 degree, reach up to the level of this C, the C dash. Then D, it is along this line, reach up to this level of the elevation of D dash, it will be D double dash, and join. This will be the side view or view from right of the line CD. Is it okay? Hello?
Yes, sir.
Yes, sir.
Okay. Now, next thing, the 3C part. Let us read out the statement. Draw elevation plan and view from left of the line EF. When E is 45 mm above HP, okay, and 10 mm in front of VP. So with reference to any XY line, what about position of E and E dash? 45 mm above HP. So E dash will be at 45 mm from XY. And what about E? The plane 10 mm in front of VP. So this is 10. So E and E dash will be placed in that way. Next thing, F and F dash. F is 15 mm above HP. So 15 mm above HP, elevation of F, and 40 mm in front of VP. So 40 mm in front of VP, here will be the plane. The projector of E coincides with that of F, very important. So the projector which connects E and E dash, it is one projector. Another projector for F and F dash, it is here. But when both of these projectors are overlapped or coinciding, so we are drawing a single projector line. On that line, mark E and E dash at 10 mm and 45 mm. On that same coincided projector line, we mark 2 points at 40 mm for F and 15 mm for elevation. Do you get my point? So on the same projector, we are working. And for our convenience, let us mark these points. This is elevation of E, this is plan of E, this is plan of F, and this is plan of elevation of F. Remaining part is simple. From plan, we draw these horizontal lines, reach to this profile axis, then draw this 45 degree line to reach the XY line, then through these points draw vertical lines and draw these vertical lines with the limitation that this line should be up to this height or elevation of individual corresponding points. So for E, this is horizontal line, this is 45 degree line, this is vertical line to reach up to the level of the height of E. So here is the E double prime, and similarly Similarly, for F, horizontal 45-degree, vertical to reach up to the height of point F. Okay, so please understand this thing, have these screenshots. These diagrams are so preliminary, primary and basic that any textbook will give you similar kind of things, obviously with some difference in numerical values, but otherwise there should not be any problem. So for 3, I will include it in a single page. Just take a screenshot for this problem 3.
Yes, sir. Take it.
Okay. Now, next thing. Now, before going to those portions, let us move back to that 3D like diagram here. Okay. Now suppose we have a line. In fact, one separate diagram I need there. Okay. So for our convenience, we draw a separate diagram. This is the XY line. This is the vertical plane. In 3D representation, this is the horizontal plane. Okay. Now suppose, now let me do some construction. Just wait a while. Now, can you try to visualize? Of course, my freehand sketch is not up to the mark, but at least you can guess something. And you should consider this length and these two lengths are equal.
Trapezium.
We are thinking as a whole for the straight line capital A, capital B. And the line AB is parallel to VP. Now, when a line AB is parallel to VP, so every point on that line is at same distance. So if it is distance of point A from the vertical plane, for every point they will be on the with the same distance. So what about the location in plane? Every point in plane then at the same distance, because distance from vertical plane we get in plane small a small b. So if this distance and this distance are same, then naturally we can say that plane points will be at same distance for A, for B, these are also at same distance. So when we have this plane of A and plane of B are at same distance from the ground line, so what about the plane as a whole? When we think the straight line as a whole, naturally draw this XY line. Here will be the plane AB. Then what about elevation? For elevation, you need to draw the projectors passing through the points A and B in plane. And finally, that distance given there in terms of the height of the point capital A and capital B will get the elevation. But there is little difference between the previous categories of problem and this one. What is that? Earlier, location of A was given. So plot A dash, identify B dash, then the distance between the projectors for A and B, those are given. Join with the straight line, it was like that. But in this case, we have to think as a whole. So if the line is making angle theta with the horizontal, then what about the length of plane AB? This one. This is L cos theta, like this. And what about the length of elevation? Obviously, it is L because the line is parallel to VP. So here in this plane elevation combination, you will find this is the true length or actual length of the line L. Length of plane is L cos theta. And the angle made by the line itself will be the angle made by the elevation with the ground line. This will also be theta. So angle made by the line with the horizontal plane will be the angle made by the elevation with the ground line. Very important diagram. Line AB parallel to VP. So when the line is parallel to VP, that means this side. So its projection on other plane will be parallel to ground line. So projection on the other plane is projection on the horizontal plane. That is the plane. That plane will be parallel to the ground line. Okay. Now let us move back to that HPVP combination. Suppose it is here. Now let us make it a little bigger. So if we have a line AB, AB is perpendicular to vertical plane. So when you see along this direction, then elevation of A and elevation of B, both of them will be at the same height, because AB perpendicular to VP means it's horizontal. Horizontal means distance of any point of the line will be same. So this height, they will be same, which is the height of elevation. And here will be the plane AB. And when we open this space to 90 degree, this is the XY line. This is the projector. Here we will have the elevation, and here we will have the plane. And such similar kind of things are given in problem number 8. That is, here. Now this diagram is very important, and it gives you the overall idea about the position of a straight line in first quadrant, various positions, and it includes all such primary information. Part A, parallel to VP and perpendicular to HP. Parallel to VP and perpendicular to HP means, suppose it's like you standing vertically on the floor. So your shadow will be, if you are a straight line, so your shadow will be a point on the floor, and your foot will be at A and your head at B. So A and B are at different locations in elevation, but in plane A and B will be at same location. So here the location for elevation, it is here. And distances will be given definitely. A line AB is of length 60 millimeter. Now, what about the length of this elevation? Definitely it will be 60 millimeter because it is parallel to VP. So projection on the VP will be of same length. Okay. Similarly, for part B, anyway, the end A is 10 millimeter above HP and 15 millimeter in front of VP. So this will be 10 and this will be 15. Next part, for part B, parallel to HP and perpendicular to VP. That description is already there in detail. When it is perpendicular to VP, so elevation will be a single point and at a distance 10 and A at 15. So naturally at a distance of 60 plus 15, that is 75, we can identify the location of plan B. Now for third part, parallel to both HP and VP. So this parallel to both HP and VP, it was this case which was given for that this line. Elevation plan length is 60 millimeter. Elevation length will also be 60 millimeter. Plan length will also be 60 millimeter. Then what about the height of this elevation for A? This is 10 millimeter. Distance of plan from XY, it is 15 millimeter. So automatically we get for B also, and elevation is parallel to XY and plan is also parallel to XY. So 10 millimeter, 15 millimeter, 60, 60, this is part C. For part D, parallel to VP and inclined to HP. That part we have discussed. Parallel to VP means its elevation will be of same length. Angle in elevation will be the angle made by the line with the horizontal plane. So theta is the angle with HP, that is 30 degree. So elevation of length L, plan AB of length L cos theta, but we do not calculate it. This is the subject drawing. So graphically we will do everything and we don't need to calculate. So once we take a horizontal line, take a line of 60 millimeter along this 30 degree inclination. So definitely drop this perpendiculars at a distance 15 millimeter. So this length will automatically L cos 30 degree. You don't need to calculate. Similarly, for part E, the line is parallel to HP. So when it is parallel to HP means every point of the line is at same height. So height of elevation will be same for every point. So when every point in elevation is at the same distance, so naturally it will be a line parallel to XY. So this is the line parallel to XY. But what about the length? Length we find from this, the angle with the vertical plane. Normally this angle is indicated by phi. Angle with VP, that is 45 degree. So this angle is 45 degree. Take a length of 60 millimeter, project it. We find this A dash and B dash, that will be elevation. We don't need to calculate the value of 60 multiplied by cosine 45 degree. Graphically it comes automatically. Okay. Clear? Is there any confusion?
No.
No.
So this ability of visualization is very important. So take a stick, maybe your wooden or steel ruler 1 foot, and place it just in that vertical wall and horizontal floor combination. First one as if it is standing vertically, the first one, then as if it is lying horizontally but not on the floor, it is lying on some bed, having that bed height is 10 centimeter or something like that. Okay, so this is the second part. Third one, you hold it parallel to the corner of your room. Corner means the corner line, the line of intersection between the vertical wall and the horizontal floor. There is the third one, parallel to that. Fourth one is you have to make the line in such a way that it is parallel to the wall. The fourth one, it is parallel to the floor, but neither perpendicular to the wall nor parallel to the wall. So it is in its that configuration at an angle phi, that is 45 degree. So length of that shadow on the vertical wall, it will be L cos phi. For the part D, the length of the shadow will be L cos theta. Okay. Now in relation to this, if you just think about surface of a cone, suppose once we think about that surface of a cone, suppose this is the base, they look like ellipse, but actually it is a circle, and if it is the top of the cone, then how this conical surface has been created? This conical surface has been created by taking a line inclined in this manner. If this angle is theta, then rotate it about this geometrical axis. So it will take different position, but everywhere the angle is theta. Angle is theta. For this 3D view, theta are showing differently, but actually physically those will be coming as angle theta when you think about this stick forming this conical surface. Now what about this line called? This line is called the generator, which generates this conical surface. Now what about the angle made by the straight line with the base or horizontal floor? It is theta always. Now in its different position, different elevation you will find. When it is directly in front of you on the vertical wall, you will get a straight line perpendicular to xy. When it is in its extreme left or right position, then it will be parallel to VP and you will get that full length in its elevation. So in that way, but everywhere it is making that same angle with the horizontal floor, and length of plane is L cos theta. So such kind of thing is here in the third one. Not third one, the case D, the fourth one. Okay, so it will be the more easy for you. Just take a stick of length 1 foot or something like that and try to make this conical surface. So once you forming this conical surface, naturally you will find different position, and in elevation you will find what about the height of the elevation of this line. This is fixed. This is the bottommost end, whether it is here or here or here, here, whatever it may be. This is the topmost end. If it is A, if it is B, different position, B1, B2, B3, etc. But one thing is sure, the height or relative height between B and A is this much. Fine. Similarly, if we take a cone and place its base on the vertical plane, here also you will get similar kind of thing, which is in part E. Okay. Now, just remember this. then we'll switch over to the last part of this problem. Not now. Let us allow that knowledge to precipitate there. Okay. But this problem 8 is very interesting and eye-opener for the straight line problems. And all details about straight lines, almost all details about straight line projection are there in problem 8, except few special information. Okay. So let us make it a little bigger. This is length L. This is angle theta. This is L cos theta. And what about this height? Relative height between A and B? क्या रे बता?
L sin theta, sir.
L sin theta. So this is length of plane. This is true length. And the line AB parallel to VP. And next case, line AB parallel to parallel to HP. This is the true length L. This is true inclination of the line with the vertical plane. So theta is angle with HP and phi is angle with VP. Now what about this length of elevation? L cos phi. And what about the relative distance between A and B measured perpendicular to VP?
L sin phi.
L sin phi.
L sin phi. We are talking mathematically, but truly speaking, we don't need this mathematical calculation. Simple graphics will give you everything. Okay. Now, when we think about that cone standing on horizontal floor, and the generator is taking different position, but one thing is true, the generator is making angle, a fixed angle with the horizontal plane, but in its 360-degree movement all along the periphery or circumference of the ground circle, it is making different angle with the vertical plane. But wherever it goes, as the line is making some fixed angle with the floor, then what about the length of plane?
So the circumference of the cone.
This is the line AB. Plane is this one. What about length of plane?
AB cos theta, sir.
Sorry. This one. B is coming at the center. A is on the periphery. So what about AB? AB is the radius of the base circle.
Yes, sir.
Okay. And it is fixed. So wherever it goes, for the same angle theta, this R is L cos theta. And that L cos theta is fixed. The relative height L sin theta, that is also fixed. But phi varies. Phi varies means it takes different position of this plane. That is one part. Similarly, for the other view, when we are considering about a cone whose base is placed not on the HP it is placed on the vertical plane, that is the vertical wall, then in that case the length of elevation will be that radius of the base circle and plan will be automatically changed. So combination of these two is to be remembered. When the line is parallel to VP, its plan is L cos theta, elevation is true length, elevation you will get the true angle. When the line is parallel to HP, then plan will be true length, plan angle will be true angle with the vertical plane, elevation length will be L cos phi, and relative distance between the terminal points of the straight line measured from the vertical plane is L sin phi. But ultimately, we should have a straight line in its projection in this way. Ground line XY, one for elevation and plan for A, another particular projector for B and B prime, the elevation and plan for capital B, and these things are connected to give us the plan elevation of the straight line as a whole, capital A, capital B. So when we think about this straight line as a whole, then what about the length of plan? Here, the line is having true length L, true angle with HP is theta, true angle with VP is phi. So length of plan is L cos theta. Length of elevation is L cos phi. This part, L cos theta from here. And what about this relative height? In elevation?
L sin theta plus L sin phi.
This is L sin theta, and the relative distance between A and B measured from vertical plane, it is L sin phi. So this mathematical information, these four information are there, and you have to satisfy, of course, with some primary information that point A is this much distance from the vertical plane in front of VP, and this much distance from horizontal plane, that is this much distance above HP. Once it is fixed, then we go for the other thing, but this geometrical four clues must be satisfied. Length of plan is L cos theta, length of elevation L cos phi, relative height between A and B is L sin theta, and relative distance from vertical plane between A and B, it is L sin phi. Okay? But we are not working it mathematically. We will work it graphically. That is, first we locate the plan and elevation for A and for A. Plan small a, elevation small a prime. Okay? With this connecting line called the projector. Then we draw very thin horizontal line. Suppose if it is the first step to identify plan elevation of point capital A. Second step, draw two horizontal lines through A. Next step, draw a line of length L at an angle theta. But when you work with your drawing instruments, pencil, eraser, etc., exactly at an angle 30 degree of exact length of 60 millimeter, that you cannot find this point. So first step, you draw a straight line at an angle 30 degree. It will be little more than that 60 millimeter. There you mark with the circular arc of length 60 millimeter taken from the scale and using the divider. Right? So that is step 3. So this is step 3. Step 3. Step 4 is at an angle phi. That is step 4. Draw a line. Measure this true length 60 millimeter. That is step 4. And identify this location. Step 5 is draw 2 lines through this point. That is step 5 and this step 5. 2 lines parallel to XY. Now step 6 is from this point drop a perpendicular. Step 6 and step 7 is reach up to this line. Step 7. Then step 8 is join small a and this point. Name of this point is B. Next, what about step 9? From this point, drop a perpendicular to reach up to this. That is step 9. Then measure this distance and use this distance as radius. Draw this circular arc to reach up to this level. That is step 10. And from this point, drop a perpendicular to this ground line. You will find this point and this point exactly matching. So this will be plane and elevation connected by a single projector. So step 1, after drawing this ground line, locate elevation and plane of A. Step 2, draw horizontal lines through A and A prime. Step 3, draw a line at an angle 30 degree of length 60 millimeter. Then step 4, measure a line of length 60 millimeter at an angle 45 degree here. Now from this point draw a line. Step 5. From this point draw a line parallel to XY. That is also step 5. Step 6 is from this point drop a perpendicular to this level and rotate this length to reach up to here. That will be plane of B. And to get the elevation from this level, drop a perpendicular. Step 9, rotate this to reach up to this level. That will be elevation of point B. And ultimately you will find if your drawing is correct, it's accurate, then B and B prime will give you that connecting same single line perpendicular to this ground line. But in no way we are calculating the length L cos theta, L cos phi, L sin theta and L sin phi. Geometrically it is coming, everything. How it is coming? Simply by drawing the perpendiculars. Now let us erase this.
Sir?
Yes.
Sir, how to draw step number 7? I mean, with freehand or with measurement?
I'll be back. I'll be back. Just let me clear this. Bundle of information. Even if we do not understand what is what and how it is happening, you just think in this way that length of plane will be L cos theta, length of elevation will be L cos phi, true length of the line is L, and relative height in elevation will get as L sin theta, and relative distance in plane is L sin phi. So first step is here. Just a minute. Draw this XY line. Okay. Then on this projector, identify plan and elevation of capital A. Then through A and A prime, draw two parallel lines. Step 3 will be at an angle theta, that is 30 degree. Measure the length, true length L, that is step 3. And through this point, draw a line parallel to XY. Similarly, along the real angle with the vertical plane at an angle phi, that is 45 degree, it is step 4, and measure this true length along that 45 degree line, that is step 4. Step 5, you draw this horizontal line. Here also draw this horizontal line. Step 6 is this one, from here to here. This is step 6. This circular arc. Step 7, reach up to this limit and connect these two points. There is step 8. There is the plane of the line AB. Am I clear?
Sir,
Yes.
what is the reference point of making arc of step 7? I mean reference point, sir.
Plan of A. Okay.
Okay, sir, got it.
Then the reverse process. From plane, we identify this location, draw a vertical line to reach up to this level. Then from here, about this elevation point, with this distance as radius, draw this circular arc to reach up to the limit. It will be elevation B prime. And whatever mathematically you are thinking, that same thing must be available in drawing also, that the connecting line B and B prime, this must be perpendicular to the ground line and a same single connecting line. But if there is some incorrectness, necessarily you will get two different locations along two vertical lines, for B one line, for B prime one another line. But it should not happen, because theoretically the elevation and plane of the other end, B and B prime, they must be connected by the same single line. Okay, now come back to this diagram, which is satisfying the geometrical clue, that is, if it is L, if it is theta, then what about this length of plane? This is L cos theta. And what about the relative height between A and B?
L sin theta.
L sin theta. Now, what about this length of elevation?
L cos phi.
L cos phi. And the relative distance in plane measured from vertical plane, it is
L sin phi.
L sin phi. That's all. So L phi, L cos phi, L sin phi, L theta, L cos theta, and L sin theta. but you have to think as a whole. A straight line is a single entity object. So its length is L, its length of plane is L cos theta, its relative height in elevation is L sin theta. Length of the line is L, its angle with vertical plane is phi, so its length of elevation will be L cos phi, and its relative distance measured perpendicular to the VP, it will be L sin phi. And if we think about the final diagram, what about this length? This length is this much because it is that circular
L
arc.
cos theta.
This length is this much, that is L cos theta.
Yes, sir. Yes, sir.
You don't need any mathematics. Now, what about this length, length of elevation? It is this circular arc.
Yes, sir.
It is corresponding to this. This is L cos phi. And relative height between A and B, this is equal to this one. That is L sin theta. And relative distance between A and B measured perpendicular to VP is this much, and it is equal to.
Instead of drawing that arc, can we use set square 45, 90 degree set square?
That you can try. There are so many options, but you have to understand and you have to justify and you have to finalize which method you have to adopt, which takes less time and gives the less possibility of making error. Okay, that comes from your practice. Otherwise, what you can do? Measure this distance or calculate the distance theoretically, and you do not know what will be the angle of this line. So, would this angle of plane has been given, then definitely you should draw a line along that inclination and measure this length there. But it is not like that. Only thing you know, this range of plane. So within that range of plane, you have to identify this distance. So that's why we rotate this line to meet up to this limit and look at this point. Here.
Sir, one thing, sir, I have understood the whole steps, but sir, then also like how that angle is coming, like finally with the horizontal and vertical plane, the final thing that I couldn't get. I
In the
understood
in
whole
the in the final thing, we do not need that angles.
Automatically.
These angles are not known.
After we complete, it will be known to us automatically.
You can measure. You can measure. It is something like that. It can have infinite solution. If you think about that cone placed on the horizontal floor, that a single straight line, that slant line, which is forming the conical surface, but in its base point movement along the 360-degree rotation about the base center, it can take any orientation starting from parallel to VP to parallel to PP. Okay, so in that case, only this clue is satisfied that whatever may be the position, the relative height between the ends A and B, it will be fixed. Only thing, it can take different position. That's all. And when it is like this, it is the true length. In other location, it is not the true length, but L sin theta, everywhere the height restriction is L sin theta. The apex of the cone and the base of the cone. That is L sin theta. When L is the length of the generator and theta is the angle made by the generator with the horizontal floor. So you just try it. Take a scale and hold with your left hand at some location and put the other end on the horizontal floor, and you try to rotate the lower end on that circle, base circle. So height is restricted, the relative height between the base and the apex, that is L sin theta. So this is the range on which it will be limited. So that's why this length of elevation is shifted to this height. This is the measurement which will be available here. Similarly, this is the measurement L cos theta. This much is L cos theta. This is L. This is theta. This is L cos theta. And that L cos theta will be measured within this restriction of L sin phi. So this is the length L cos theta within this restriction L sin phi. So these four geometrical restrictions are there. That is length of plane, length of elevation, relative height in elevation, and relative distance in plane. That's all. And we are working with the straight line as a whole. When only 5 clues are there, true length of the line 60 millimeter, true inclination of the line with the horizontal plane, that is 30 degree theta, and true inclination of the line phi with the vertical plane, that is 45 degree. And one more clue, otherwise it will be infinite solution. The location of point capital A, that is plane and elevation at 15 millimeter from VP and 10 millimeter from HP. That's all. And then we are working for the solution as a whole, not like the previous problem. That is A is at such and such location, B is at such and such location, and distance between the projectors through A and B is this much. Not in this fashion. Here we do not know the true length of the line. We do not know the true inclination of the line with HP, that is theta, or true angle made by the line with the vertical plane, that is phi. Those things are not given. Only thing, just in some abstract manner, location of A is given, location of B is given, and distance between the projectors through A and B, that is given. But in no way it is the real line we are talking about in this normal regular fashion. There is a straight line of this much length and this much inclination, theta and phi, in that way. But the primary clues are coming from these previous diagrams. What are those things? Just a minute, I will clean this. True angle made by the line with the horizontal plane, true length, true angle made by the line with the vertical plane, with its true length L. That's all. L theta phi, and this location is to be given. Otherwise, it will be infinite number of solutions without having any real position of point A. Okay. And from this thing, this is L cos theta. This is the height restriction. This is L cos phi, and this is the distance restriction. That's all. And geometrically, we are satisfying those things here. But before the okay, in the diagram above, this one, we do not know these angles, but geometrically it has been satisfied that length of elevation L cos phi, height of elevation L sin theta, length of plane L cos theta, and relative distance in plane L sin phi. And it has been satisfied from these primary clues. Okay. So what about this primary clue, L theta phi and position of A? It is there. Next thing, the starting point for A. after locating A and A dash at an angle theta, take a length L and project it on this horizontal line. Next step, L with phi, this one and this one, and geometrically we are satisfying by drawing horizontal passing through this elevation height and this plan distance. These two things are the major clue regarding location of the point B in elevation and in plan. Those things are here. This one and this one. So step 1 is this. The gross step 2 is this. Of course, this part is repeated there. And next thing, this length to be measured along this line. And length of elevation, this length to be measured here for this height restriction. Okay. Nothing to worry. You just start with these steps as we have discussed, and you will reach to this final diagram. No problem. If you need, I can repeat the whole process starting from the beginning. Draw the ground line.
Only the problem E was a bit confusing.
Problem E. Last one or what? Or parallel to HP and inclined to VP? This one.
Sir, no sir, F, where two angles are given.
This is the combination of this one and this one. But combination of these two will give you those geometrical conditions to be satisfied. One is here L cos theta and L sin theta. Here L cos phi and L sin phi. Because straight line is a single object. This is one orientation, this is another orientation. Here is the combination. In this case, line is making only angle theta with the horizontal plane parallel to VP. Here it is line is making only angle phi with the VP, but it is parallel to HP. Suppose you have a cot beside your wall, okay, and you can, while sleeping, you can take different position. On the cot when you are sleeping, definitely you are in your horizontal position, parallel to the floor, is it or not? Are you confused? You have a cot in your bedroom. When you are sleeping, definitely you are horizontal on that cot and you are parallel to the horizontal floor.
Yes, I understood this part.
ठीक है? और नहीं तो 3D फिर draw करना पड़ेगा.
No sir, I understood the analogy.
So when you are sleeping on the cot, you can make your body perpendicular to the wall. You can make your body parallel to the wall. And it may be in between. You are inclined. Okay. So when it is inclined, but still you are horizontal. You are lying on that horizontal cot. So your body is parallel to the floor. every location of your body, whether it is head or your foot, it is at same height, which is the height of the cot. So that is elevation of every point between the ends A and B. Every point is at same height. That is coming here. Height at your head, height at your foot, height at different parts along the straight line, it is same. And when you take different position, it may be like this, parallel to the wall, it may be perpendicular to the vertical wall, or it may be in between. Okay.
Yes,
But
sir.
at the same time, the straight line may make angle like we have considered the surface of a cone. This conical surface is made by rotating this straight line. It is a single straight line, but this is a fixed position, the extreme position. It could be here also, giving a combination of theta and phi. This is theta. This angle is also theta. This angle is also theta. But in 3D view, this theta are looking different. But for every such position, we are getting different phi value made with the vertical plane. That is with the wall. With the floor, it is making same angle theta. So if we reach to certain position, suppose if this is the position where the line is making angle phi, so length of plane, length of elevation, height restriction in elevation, and distance restriction in plane, those things are fixed. These four geometrical cues are to be satisfied in this final diagram here. Length of elevation L cos phi, length of plane L cos theta, height restriction L sin theta, and L sin phi is the distance restriction. And that we are getting from these two primary diagrams, this one and this one. What you start with? This one, A, B, C, D, that we are coming from the diagram D. And from diagram E, we are getting this. Okay. So from diagram D, we are getting this length of plane. From diagram E, we are getting this length of elevation. Then you need to satisfy these two clues, relative height, carrying the L cos phi. So this is the relative height. Geometrically, we draw this line and this length to be measured here. And that is geometrically we are doing by this circular arc. Similarly, this is L sin phi is the geometrical restriction, the distance restriction, and for whom this length of plane. This length of plane to be mapped on this restriction by this geometrical process, not by calculator. Taking this point as center, this distance as radius, and identify this location. I'm sorry, because this problem is not due to your level of understanding, not due to my level of teaching. It's not like that. It's everything comes from that pandemic situation. Once you are in the real classroom and I am in front of the blackboard with the chalk and duster in my hand, then nothing can be superior to that combination. The student, teacher, the classroom, and the blackboard. You cannot replace that. But I understand situation does not permit. So we are trying our best to reach the information up to you. And from your side, you have to put some additional effort to help your teacher so that things are, because for this subject, I must mention, there is no attachment, no root from your school level knowledge. For physics, for chemistry, for different computer science subjects like the basic language, C, C++, basic, etc. You have some connection. But this subject, there is no connection, and ability of visualization, it is so important. It plays so major part of this subject. Then necessarily it is very difficult for this distance learning. It is very difficult, but I'll be very naturally, I am hopeful. I have complete belief on your ability and your patience, your interest on this subject. And please go through lots of videos available in YouTube and other things, and some video lectures in NPTELs, etc. And this detailed diagrams. Okay, I just erase all these additional information. So please have one screenshot of this problem number 8 and its part solutions, so that at your leisure time you can go through this thing and you can understand what is what. Okay, so maybe right in the class lots of informations are gathering there in your that brain, and it is not giving you proper support at this moment to understand everything. But it is not difficult at all. It's not like difficult differential equation, or not like any other. Now you may not need this thing to copy, because this information is already there through the mail. Problem number 8. Only thing, I'll make this thing little bigger. Okay. This is for 8A, 8B, 8C, 8D, 8E, 8F. And F is combination of D and E. Okay. The first one, when somebody is standing on the floor, but not directly on the floor, you are standing on the cot, or on the table or chair. So there is some gap between the floor and your feet or the toes. Here you are lying horizontally on a cot perpendicular to the wall beside you. Here you are sleeping on a cot parallel to both the floor and the vertical wall. Here you are inclined. Suppose you are raising your hand, not vertical nor horizontal. It is inclined and raised forward when your hand is parallel to the vertical wall. And in this case, similar kind of thing. Your hand is horizontal, but neither perpendicular to the wall nor parallel to the wall. There is something in between. And here it is the combination. So please provide some time for this 8. And once you understand this part, the final stage of a straight line, it will be very useful for you for the other problems when these parts are not given. You have been given only this plan and elevation. Okay. Then you have been asked to find out this plan elevation are given. Find true length, true angle with the horizontal plane, and true angle with the vertical plane. Follow the reverse step. Reverse step means make the line here in AB and A dash B dash, both these, out of these two, none of them are parallel to or individually parallel to the ground line. So when any view is parallel to ground line, then other view is the true length and true angle. So if we think about that, we make the plane parallel to ground line. So B comes to this location B1, then maintaining that same condition, this point moves to this point. Okay. So now this becomes the true length and true inclination with the horizontal plane. So this thing is utilized. Okay, so first step, rotate back to this level, shift it to this vertical restriction level, connect these 2 points. This length will be true length and this angle will be true inclination theta. And the diagram E will help us to find out the angle phi. So this reverse process is also very important. When this length L, this angle phi is given there, that means instead of keeping that elevation inclined, we make that elevation parallel to GL. So this is the elevation, we make it parallel to GL. Suppose this is another position of the end B. So corresponding plane will be here, because elevation and plane are connected by a same projector line, and this is the distance restriction. So naturally this will be the true length L, and this will be true angle with the vertical plane, that is phi. So it may be given, one such similar problem is there. Here. So elevation and plane are given. So first step, make the plane parallel to GL, get the corresponding elevation. If it is B1, it will be elevation of B1, and connect to get the new elevation. It will be true length, it will be true angle with the horizontal plane. Similarly, make the line parallel to, or make the elevation parallel to GL, get the corresponding plane. That means this is the combination gives the true angle and true length with the vertical plane. Okay. So that problem 8, you just take a time for different, because this visualization is very important. Perpendicular to horizontal plane, perpendicular to vertical plane, parallel to both the plane, inclined to HP but parallel to VP, inclined to VP parallel to HP, and this is that L theta phi combination. And reverse may be elevation given, plane given, these blue lines, and finally L theta phi. Follow the reverse process. First make this kind of diagram where, this one, where we get the true length and true inclination. So elevation parallel or plane parallel. But in both the cases, length of plane and length of elevation must be maintained. That is, length of elevation, when you make the elevation parallel to GL, corresponding elevation will give you the true length and true angle with the phi, or with the VP. Similarly, the other one. So, any question? Maybe right at this moment you cannot ask any question because you need some time to precipitate, assimilate, and please go through different problems, and with the help of these individual solutions. But definitely I understand your situation, because this subject, it is not so easy to communicate in this online mode. Okay, then let us try one more thing. In the first quadrant, there is a straight line AB. Sorry, before going to any further discussion, I need to do that important thing. What is that?
Attendance.
Attendance. It has been reduced 119 only. So डर लग रहा है बेटा? डरने का कोई बात नहीं.
No, sir, please end the session because we have class from 5 of EC.
Sure.
Yes, sir, extra class is being taken by sir from 5 to 6:30. Then it will be continuous for 5 hours.
sir.
Okay, definitely I'll do. But a very important thing, otherwise they will be rather in some trouble. Okay. Do you find any page there? One VP, HP, straight line AB in first quadrant?
Yes, sir.
So next thing, what we do, we extend the, this is the projection of the line. Project on the vertical plane, elevation A dash B dash, project on the horizontal plane, plan small a small b. Okay. Next thing what we do, extend the line. Oh no, before going that, we have done this thing also. These projectors, these green lines, because when you open, these two lines will be overlapping as a single line perpendicular to GL. And this is the formal presentation on a 2D surface. There is the XY line, elevation of A, plan of A connected by a single projector perpendicular to GL, elevation of B, plan of B connected by a single projector B, and this is the elevation plan of the straight line capital A, capital B. Here we do the next thing. The line AB is extended downward to meet the horizontal plane. And where it meets the horizontal plane, it is called the trace. The point of intersection of the line with the horizontal plane is called the horizontal trace. Now, when we extend this line downward, naturally, its individual projections are also extended in this way. So elevation of A dash B dash will also get extended along this direction, and plan also will get extended along the same line. And in this diagram, you will find this elevation is extended, the plan is also extended corresponding to extension of this line. Now, as this line is extended to meet the horizontal plane or the floor, then what about the corresponding elevation? Elevation will be having no height, that is on the ground line, and that is on the elevation line, and plan will be definitely the same location, and it is located on the plan line extended. And this part is very important, this diagram. Extend the elevation, that is step 1, extend the elevation to meet the ground line and get the corresponding plan. Definitely plan will be along this projector line connecting plan and elevation, that is primary clue, and that is on the plan line. So extend the plan line AB. In fact, you cannot get the point directly, that HT, in that way. So what normally we get, we extend this line by our eye estimation a little bit. We extend this plan after this. We get the point of intersection, mark it there, that is the HT. So extend the elevation A dash B dash to meet the ground line, that is first step. Step 2 is locate the corresponding plan, that is HT. Plan of this point will be HT because HT is the point on the horizontal plane and elevation of that point definitely on the ground line. So on the extended plan AB, extend this line, drop a perpendicular projector, get the point of intersection, that is horizontal trace. And to get the vertical trace, extend this line upward. The line AB is extended upward to meet the VP. That is called the vertical trace. And how we get it? Definitely this point is on the vertical plane, its plan will be on the ground line. And of course, plan is on this extended plan and this point is on the extended elevation. So this is the process. Extend the elevation, extend the plan. And this is the formal plot on 2D drawing sheet. Plan is extended to meet the ground line, that is step 1. Then find corresponding elevation. elevation will be on the elevation line extended, and definitely it will be located on this connector or the projector. Okay. So this is the process for the whole thing. Line AB, A dash, B dash, other line capital A, capital B is given, whose plan elevation is like that. Extend the elevation to meet the GL, corresponding plan will be HT. Extend the plan to meet the GL, get the corresponding elevation, that is on the vertical trace. So you take a screenshot of this page for your future reference. When it is done, you just tell me.
Yes, sir, done.
Next thing, for horizontal trace, get a screenshot of this diagram.
Yes, sir.
So this horizontal trace, vertical trace are another important thing. For problem 10, this diagram is there on the page number 3. It is there. So find the HT and VT of the line shown in figure 10A and that shown in figure 10B. Now for 10A, it is extend the elevation to meet the ground line, get the corresponding plan, that is HT. Extend the plan to meet the ground line, get the corresponding elevation, that is VT. But there is something special in 10B. Get the elevation, the extend the elevation to meet the ground line, but its plan is not below the ground line. Its plan is definitely located along this vertical projector line and also located on the plan line extended. But that point on the horizontal plane, it is above the ground line. So physically, can you tell me how does it happen? If we have a straight line, here, not necessarily the points will be coming on this vertical plane and this horizontal plane in this way. Suppose line is extended to meet the vertical plane, it will be VT. But it is not meeting the horizontal plane until unless the straight line piercing through the VP and meets here on the horizontal plane, that is HT. And when you rotate this, so naturally this point will shift upward, and that's why that thing is here, the HT. But VT is as usual, it is here. Similar thing could happen for some other situation, that is here is the line AB. You extend it, it meets the horizontal plane here. Sorry, it is HT. But the vertical trace is here when it is meeting the vertical plane, but it is below the XY line. So in that case, HT and VT will be both below the ground line. So nothing to worry about all such situations. Just follow this simple process. Extend the plan, get the corresponding elevation, extend the plan to meet the ground line, get the elevation on the corresponding extended elevation, it will be vertical trace. Extend the elevation to meet the ground line, get the corresponding plan on the plan extended, it will be the horizontal trace. That's all. And once we have that HTVT, etc., then other situations are very simple. For 11, you take the, you have that problem statement. You have this diagram also. Just take the screenshot of the solution page of 11A, B, and C. In our next class, we'll discuss in detail, but not right now. You don't have time before 5. We don't have much time. So please take a screenshot for problem 11. When it is done, you just tell me. Done. Okay. For problem 10, it was already there. Before that, we had that HTVT, etc. And next problem is problem 14. It is simple. Of course, we have 5 straight lines there, but you have to think as a whole, that bundle of those 5 straight lines with that logic. Draw plan and elevation of a regular pentagonal lamina of side 30 mm when it is parallel to and 20 mm in front of vertical plane. One edge being HP. So this solution is self-explanatory. Part B, draw plan elevation and view from left of the same lamina when it is inclined to the VP at 45 degree and perpendicular to HP. So this is for part A. And its continuation helping this part A solution, part B. This angle is 45 degree. You take a cardboard, make a big pentagonal plate-like thing there, and hold it in front of the vertical wall, parallel to the vertical wall. Its plan will be a single line parallel to the ground line, and in its elevation, it will be the exact shape of that pentagonal lamina. Next, we should give the names of different corners. A, B, C, D, E in elevation, and corresponding plans will be A here, B dash B, C dash C, D dash D, E dash E, because the whole thing is represented in this form of a line. So as if the sun is just above your head at 12 noon and you are holding a plate vertically. So naturally shadow will be a thin straight line there. And plan elevation. Now 5 straight lines are there, but we are not talking about these lines separately. It is clubbed in this fashion, giving you that logic of 72 degree or 108 degree included angle. And those things are available when it is giving us the exact shape of this. Next one, we make it incline, not keep it parallel to the vertical plane or that vertical wall. Make it inclined at an angle 45 degree. So you rotate this line about the point E through that angle 45 degree and name these things. Copy the whole thing EA, AD, DB, BC, etc. here on this line, and heights will remain in its original position. The same original height will be maintained. So A, its elevation will be on the ground line, B elevation will be on the ground line, because one of the sides, one edge AB being on HP, means elevation on the ground line. Other points, they maintain their original height measured from the floor. So E along this vertical projector, along this height through this elevation E prime. Then B on the ground line, C along this vertical projector line and at this line height, at this horizontal line. Similarly, D, the central point, it is elevation along this vertical projector line and its height restriction is up to this level. So draw this 5-sided figure. It will not be a regular pentagon like this. So here 20 millimeter, 20 millimeter, 30, 30, 30, everywhere 30 is available. Here it is not. And this is the side view that you know, draw a 45-degree line through ABCDE, draw horizontal lines, get this point of intersection, through them draw vertical lines and satisfy the height restriction of each corresponding point. A, it is here, B is here, then C, horizontal, vertical, height, D, horizontal, vertical, this height, and E, this horizontal, is vertical up to this height. Clear? And last one. Before going to that, you just take a screenshot of this. Okay. So one thing I can do, I can expand this diagram without the problem statement because that problem statement is already there with you. Or anyway, things are coming bigger, you can take the screenshot. Okay, is it done?
Yes, sir.
Yes. Oh yeah. But
Yes,
next
sir. Oh,
one
yeah.
is not complicated, but it is time consuming. What is that? Just go through this problem statement. Draw plan and elevation of a circular lamina of diameter 50 millimeter when it is inclined to HP at 30 degree and perpendicular to VP. Its center being 40 millimeter above HP and 35 millimeter in front of VP. And part B, draw plan and elevation of the same lamina when it is inclined to HP at 30 degree and one of its diameters is parallel to both HP and VP. Its center being 40 millimeter above HP and 35 millimeter in front of VP. Again, I am sorry that I cannot take your offline class right now. So with some real physical model with this circular plate, etc. is not. But the only thing we assume this circle, this continuous curved line, as if it is a polygon of 12 sides of 12 points at an interval of 30 degree. So first part, we make the plate parallel to HP. So it will be a line parallel to ground line in elevation. This distance will be the diameter. In plan, it will be the complete circle at an interval of 30 degree for this 50 millimeter diameter. Mark these points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then this is the elevation when this lamina is making 30 degree with the horizontal. So naturally this line to be made inclined. Now take this angle 30 degree and copy this line 1 to 7 in this 30 degree inclination. Mark these points 2, 12, 3, 11, 4, 10, 5, 9, 6, 8. And when you rotate it, all these points 1, 2, 3, 4 up to 12 will maintain the same distance from the vertical plane. Same distance from the vertical plane. And we do not calculate it. We simply just satisfy it by geometrical construction. That is, if we draw a line horizontal parallel to XY through this point 1, so naturally at its new location also the point 1 will be located here. So similarly for 2, plan will be along this projector and at this distance. So this is point 2. Similarly for point 3, plan will be along this vertical projector and at this distance. So horizontal line through 3. So this is the primary or basic diagram. Then for 4, it is here, this way, 5, etc. So identify all these 12 points and connect them with a smooth freehand curve. Definitely it will be one ellipse. So as you make this circular plate inclined with the horizontal, so shadow definitely will be not this full circle, it will be squeezed along this diameter, and it is the ellipse having major axis as the diameter of the circle, and whatever the length of this minor axis, it is diameter multiplied by cos 30. And the next part, you need to copy the whole plan. This whole plan you need to copy it through 90 degrees. That means this line connecting 1 and 7, it becomes perpendicular to that, or line 4 and 10, it becomes parallel to both the planes. So 410 line is parallel to horizontal, 410 line is parallel to vertical, and this thing is copied through 90 degree so that one comes here, then 1-7 line which was earlier horizontal, now it has gone vertical. Then starting from 1, 2, 3, 4, 5, 6, etc. are copied, and this copy is by simple coordinate plotting. So along this vertical line, identify any location to draw this, and with reference to this line and this line, go on measuring this thing. So once you know this point 1 there, so at this much distance downward and at this much distance towards right, identify point 2. At this much distance downward and at this much distance towards right, point 3. And the mirror image point for 2 it is 12, for 3 it is 11, etc. due to symmetry. Then you join these 12 points. Correspondingly, repeat the same process of this diagram, the previous one, for 1 on the projector through 1 and at this level. Here it is 1 for 1. For 2 along this projector at this level. Similarly for 3 along this projector and at this height. For 4, the extreme location along this projector and at this level. So please understand these steps at your leisure hour. Things are not difficult, but only thing there should be some rather from your side there must be some investment, your time, your intelligence, your zeal to understand anything new. Okay, so please take that screenshot for 18. Problem statement is already there. Is it done? Yes, sir. Okay, so please go through these screenshots and try some freehand practice on some A4 white pages with drawing instruments, etc. Because toward the end of the semester, I had to take some tests. So without practice, it will be very difficult for you to work with this thing. This is not your maths, physics, chemistry, or computer science subjects, or electrical, or something like that. This subject not difficult, very simple, very easy, very interesting, but it has no connection of your school level any subjects except your common sense. Okay then. So if any specific thing you require, you can ask later also. Just jot them down.
Sir, will the exam be 4-hour duration?
No, exam will be not necessarily of a single day exam. It may be assignment type for different days. Maybe for plate number 3, projection of point line surface in some staggered manner. On straight line, I will take half an hour test on one day. On next day, maybe half an hour test for this.
The straight line will be easy, but if we go on taking the
Straight line will be easy.
the-
I can challenge you. I can challenge you.
No, sir, no problem, sir. Easy questions.
Pentagon, hexagon, ellipse, etc. Those things are easy, but time consuming. Lots of points will be there. For straight line, only 2 points are
Yes, sir.
there. Only A and B, the terminal points. But situation may be so complicated with so many information. To connect those things logically, it will be very difficult. Straight line is the most difficult thing. And after this surface, there will be projection of simple solids. Okay, so please go through any textbook, and there you'll find so many information little advanced, so that when we discuss in our next class, we'll be in some advantageous position. And of course, I'll try to send some material in advance so that you can go through those also. Okay, so तब तक के लिए आज्ञा दीजिए.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
So please take a 20-25 minutes rest and join your next extra class. Okay then.
Yes, sir. Bye, sir.
Thank you, sir.
Bye, sir.
Thank you, sir.
Good night, sir.